Before diving into the code, I want to present a brief animation as to what's going to happen in the code. In a previous video, I defined a structure type person. So that's where this person type comes from. So I refer you back to that previous video, which is titled Structures. Now in this particular video, I am dynamically allocating an array of pointers to person structures. So I'm going to dynamically allocate both the array and then each individual element of the array, which will be a type person structure. So on the first line, right, I've defined an array length of 3. And on the next line, I am declaring a pointer to pointer. That's the star people array, and I'm setting it to null. So on the right side, you can see in the main stack frame, the people array variable is set to null. Now on the next slide, I am dynamically allocating the array. So you can see that in the heap, the array gets allocated and it has size 3. Now at this point, these person pointers are not allocated. They may be allocated to null. I think it depends on the OS, and we'll test things out to make sure that, check if they're allocated or not to null or set to null. But I don't believe that you should trust things to be automatically set unless you're programming in C++, right? Because C++ does that for you. But anyway, so then the next thing we need to do, once we've allocated the array, then we need to set the array size or set the elements to null, just so that, we're assuaging our fears, right? Okay, now, this would work in the structure video because we knew how long the array was as far as the way that the array was allocated in that video. But this code will not work, okay? And we will have to keep track of the array size. In this particular case, I'm just going by the array underscore length symbolic constant that's set to 3. But you could track it in a separate variable if you wanted to, okay? But as far as dynamically allocating how much array has been allocated, that's pretty challenging, okay? Well, it's not even challenging. I just think you can't do it, all right? So you have to keep track of the array length some other way. And that is because, right, you're not telling when you dynamically allocate the array, even though you're allocating, you have the array length calculation there, right? But you're not privy in the main method or wherever this code takes place. There is no static allocation of array, right? This is all dynamic stuff, right? So when you try to figure out the size of that pointer, which is the people array, you're never going to get the full length of the array or the total number of bytes, right? So you have to keep track of that. So that's why I have that lined out. So you'll have to use array length instead. That's what this size is showing, okay? Either, like I say, defined as a constant or defined in a variable that you're keeping track of, okay? And then, so I'm setting each element to null just to make sure it's set to null. And then then I'm going to allocate, in this particular case, a person structure, okay, dynamically. So the first element of the array, and you can see on the right-hand side in the heap, I have actually then created an object in memory of type person. And at this point, we cannot trust that the strings are set to any default, right? So we're going to have to set the strings to some value, okay? Now, let's take a look at how this all looks in the code, and then we'll run it on Mac OS and Windows, and we'll see what the default allocations are for the array itself, the elements of the array, and then when you initialize, when you actually create a structure. Okay, all right. Let's see you in the next section. Here we are in Mac OS, and I'm using iTerm. So let me go into my development folder. CD dev, and then CD C_bootcamp. And I'm going to make a folder for the project. So make dir, and then dynamic array element allocation. And then I'm going to change into that directory. At this point, we can open up Visual Studio Code. So launch code. And here we are. You should be able to see the code. I think it's big enough. So let me first get rid of this welcome window and create a main. So main.c file. Okay, so I'm going to reuse some of the code, obviously, from the structures. So let me go back to the iTerm, and I'm going to cat / structures main.c. All right, so let me scroll up a little bit. I'm just going to grab the first several lines here. I'll grab that comment and create a new type with type def, and I'll get that function declaration. I'm going to have to change that one, but anyway, that's enough. Copy that, and then just paste that right into the code. Okay. Now, so demonstrate dynamic array allocation. Oops, array element. Now I'm going to need, so I've got standard IO, string, and I'm going to need standard lib as well. So I have a string length of 25, max string length, symbolic constant of 25. And another constant of array length 10 in this case. So 10's fine. I have my person structure, which has a first name, middle name, last name, and then each one has been allocated 25 chars. And then I've created a type def with person. So that's from the previous video. And then I have this function here, which a prototype to print the contents of the array, right? Whatever data is contained in each of the elements. So let me flesh out the main function. So int main open brace, closing brace, and just return 0. Okay, let me give a few more spaces here and save that file. Okay, so just like I did in the intro slide deck, I'm going to declare an array of person to person, so a pointer to pointer, right, called people array, and I'm going to set that to null. And then I'm going to actually allocate the array. Now you could do this all on one line, right? But in this particular case, and I'll close this down, I wanted to not have the line go out much too longer. Okay. So in this particular case, now I'm going to say people array equals, and then malloc size of person pointer, okay, times array length. Just like that. Now that gives me the array. Now, when you dynamically allocate arrays, you don't want to be doing any operation on the dynamically allocated memory space unless you verify that, yes, it has actually been dynamically allocated, right? So I'm just going to put a check in here. So if people array So if that's why I like to set it to null, right? So it's like I know I set it to null, so that when the allocation takes place, then that should be something other than null, which would be true. Okay, so then I come down here now. If that did not allocate, I'm going to say else and just give a little brief error message, printf. And I'll say memory allocation failed. For people array. Like that. And then semicolon. Don't forget your semicolons, my Python friends. Now here, I'm going to then set each of the elements to null. Well, let's see what they are set at first, right? So let's go ahead and... is there a good way to do that? Perhaps. But, you know, like I say, I'd rather be safe than sorry. Okay, so I'm going to go ahead and make sure that each of those elements are null. All right, so for, I'm going to just iterate over the array. So for int I equals 0, I less than array length underscore length. Okay. Array underscore length, and then I plus plus. And open brace, closing brace. Sometimes you can't see your own errors right in front of your face. Okay. Now, here, I'm just going to step through each element of the array, like I say, and I'm going to say people array. I equals null. All right. And that's fine. Okay, that's good. That's the first start, right? So for, just go ahead and allocate each of those. Well, I'm not allocating them, just setting them to null. You're setting each pointer to null. Now, so then I'm just going to do the first one, right? I'm going to try the first one, see if that works, and then I'll allocate the rest. All right, so then people array, element 0 equals malloc, size of, and then a person. Because at this point now we just want to create a pointer to a, we want to allocate memory for a person somewhere in the heap, and then assign that address to the element, to the people array element, or to the first element of the people array. And then once we have that done, again, we want to check to make sure, which is why I set these things to null, right? Just to be sure that they're set to null, is I'm going to then say if people array, okay, 0, if that's been set, then it's safe to then operate on this people array. Okay, on this element, I should say. So then I can access each element. Now what I'm going to do is I'm going to set each of the person properties to a value, and I'm going to do that with the string copy, or strcpy function. So str string copy function, and the string copy takes a target and then the value that you want to set that target to. So the target in this case has to be an array. And so if we go up to the struct, right, we see that the first name has a length of 25. All right, so I'm just going to say people array, and then first element, 0. And then it's a pointer, so you do indirection operator, first name, comma, and I'll say Corley. Put a space after the comma. Corley, just like that. And then semicolon. Now I'm just going to come and copy these. I'm just going to copy 2 more lines, save some typing, and set the middle name and last name. So people array first name, people array middle name, and people array 0 element or first element last name. And then Corley, Sarah, Miller. Okay, now that we have this, we can test that and see what the values are. Okay, so I'm going to do printf first name colon %s for a string, and then /n comma, and then people array 0 first name, like that. And then print that, and then I'm just going to copy this again, save some time typing. So first name, middle name, and last name. Okay, so first name, change this, and last name. All right, so save that. Now we have something we can print at this point. So let's go ahead and do that. So I'm going to save my file. Go to iTerm, clear the screen, compile, gcc main.c. Okay, and then clear the screen again, and then run it /a out. Okay, so that seems to work fine. Now let's set the other elements to some default value. Okay, so I am going to return to the code, and then right underneath of here, I'm going to say for int I equals 1. So I'm going to start at the second element. I less than array size. And then semicolon, I plus plus. Okay. Oh, array length. I'm losing my mind. All right. Open brace, closing brace. And now I'm just going to do like a string copy like this. I'll just copy these 3 because I'm going to do a string copy on each one of those. All right, so I, in this case, right? So I'm going to change the array, people array element I. And then I'm going to change this to, I'll tell you what, sometimes this IntelliSense can be quite annoying. It pops up all the time. All right, first name, Jane. And J, Doe. Okay, Jane Doe. Now, strcpy. Okay, so I don't know how that got to be int state I. There we go. Okay, so people array I, people array I, people array I, first name, middle name, last name. And then let's make a method now, okay, to print all this stuff, right? So I'm going to come back up here, and so we need people array, and we need a size. Well, that will still work, I believe, right? So let's try this. Okay, so person array size. So we're going to be passing in this array, and we're going to be passing in the size as well. All right, so let's go ahead and define that function down here. I'm getting these errors here, lines. Get rid of that line. Must be some secret codes in there that I can't see. All right, so return. All right. Let me define that function. I'll get rid of that right there. Let's see what else. Anything else I see causing the reds here? Person, if people array, that should be fine. Let me compile this just to make sure this compiles. Those red lines are making me nervous. So CC main. Okay, looks fine. So let me just go back to the code here and come down here and define the function. So the function is, I'll just go copy this. Control C. And come here. And then open brace, closing brace. Okay, so for int I equals 0, I less than size, I plus plus. Now, in this case, I'm going to check to make sure that the elements are not null. Okay, so here we are going to run into an issue, right? And that's because naively, right, I'm charging ahead and I say, oh, I'm just going to go ahead and allocate this stuff, but I have not allocated each of these elements. So the first thing I need to do in this for loop is I need to allocate the person for I. Okay, you guys were probably yelling at the screen, you didn't allocate the stuff. All right, so people array I, okay, equals malloc size of person. Now, just like earlier, sorry. Okay, so I've allocated that. And then I'm going to say, like, if people array I, so in other words, if that allocation was successful, then I'm going to set these values. And just put that right there. The reason that I remembered to do this was because when I'm down here in this function, I need to do that, right? So here, I'm just going to say if array I, okay? In other words, if that element is not null, then printf, okay? I don't need that. I don't think I do. Let me add another star here. Okay, so that seems, so I'm going to need to go up here and modify my prototype. Okay, so now if array I, okay, and this should be a person array, right? So person array I, if that has been allocated and it's not null, then print out, right? So I'm going to say person, and then, oops, I need a quote. So person, and then %d, and then colon, and then %s /tab or /t %s /t and %s/n, and then comma, and then I, which is going to be the person count, okay, with the person number, and then array I, and then indirection, first name, comma, and I'm just going to come down here so it doesn't go too far across the screen, give it a tab, and then array I, indirection, middle name, comma, and then array I, indirection, last name. Now let's give this a whirl. Now we have to call this. All right, so have I got all my mess ups? All right. I'm not screwing up too badly here. So that there's no errors there. All right, so now once we have this, we need to call it. So we have this function, and I'm going to call it right here. So print people array, and I'm going to send it in the people array. Okay, and then the size, array length. All right, now we should see something. So let's take a look at the code. Quick review. Everything is saved. Now let's go ahead and compile. GCC main. All right, so clear the screen and run it. All right, so that looks like it works. Now, what we need to do is once we have we're allocating memory dynamically, essentially, okay? So we need to deallocate the memory when the program, before the program exits, okay? So I'm not doing that yet, right? So shame on me. So what I need to do is, first off, this is the rule of thumb. 1, you need to deallocate the individual elements, and then you need to deallocate the array itself. If you try to deallocate the array before the elements, then you won't be able to then deallocate the elements because your access to the array has been removed out from underneath of you, right? So I'm just going to use another for loop to say for int I equals 0, I less than array length I plus plus, okay, and then open brace, closing brace, and then if, again, we're going to do that check, array length, people array I. So if that's been allocated, then I'm going to free people array I, like that. So I'm freeing up that element. Now once I have the elements free, then I'm going to free, okay, the people array. All right, so save that, run it to make sure everything still works. And then once this runs, I will, let's clear the screen, step through and comment each line as a review. All right, looks good, okay? So, to review. In order to dynamically allocate memory, you need to include the standard lib header. And because you're dynamically allocating the array, here I've got array length defined. You can either, have it in a constant. If it's a constant that you're using, you're never going to be able to change the length of the array. You can't change an array anyway once you've allocated it, right? You have to create a temporary array, copy the elements to the temporary array, and then recreate a newer, bigger array if you wanted to grow the size of an array, right? For those people who are used to using like lists in Python and lists or generic types in Java and C#, right? Arrays underlie those things, right? If they're list types, arrays are they are dynamically allocated, and then when you they start off at a certain size, and when you keep on adding elements, right, they will grow, and that grow process is just like I described. Create a new temporary array, copy the elements to the temporary array, reallocate more space for the primary array, and then copy the temporary elements back over there. And that's how you get a bigger size, right, internally. And it's all transparent to you. You don't see it happen. All right, so on this line, I am allocating memory, right, heap space for array. Actually, I'm not allocating it here. I'm just declaring the array. So let me backstroke. So declare an array of pointers to person structures. Okay. Then on this line, I am allocate memory for the array. In this case, right, the array length is set to 3 or 10, right? 10. It was 3 in the intro slides, right? It's 10 here. That shouldn't bother you, right? I mean, as long as that's why you do these symbolic constants, right? You don't really care what the length is. As long as like a gajillion, right, and it runs out of memory, you're good to go. So then, once you allocate memory for the array, then you want to check to ensure allocation succeeded before access. Okay. Now, once that check is fine, if that array, if that allocation was successful, this will not be null, right? It'll be a value, which is why I set these to null. Then I'm going to set each of the elements of the array to null, just so I know that they're at some known state. And then in this particular case here, I'm just creating memory. I'm allocating memory for a particular person, for a person structure. Okay, and then again, like the people array, once that allocation completes, you want to make sure that it was successful before trying to access that element, okay, and setting properties on that structure. Okay, and just to reiterate, if you watched the structure video, right, where I was dynamically calculating the length of the array and the number of elements that it contained, for a dynamically allocated array, you got to keep track of the size. Okay, you got to keep track of the size. And I'm going to give a big shout out as I conclude this video to a student, right, Amy, in my C bootcamp, who pointed out the flaw in my original. So I had done this video before, and I only allocated memory for the first element. I didn't try to allocate memory for the rest of the elements, right? So the dynamic, calculating the elements like I was doing in the previous structure wasn't working, right? And to me, that was an eye-opener, which kind of tells me it's like, when you write code, make sure you're testing it to make sure it works. But thank you, Amy. I guess some people would be, what's the word I'm looking for? Offended that a student, right, And I don't consider Amy a student per se. I think she's a peer at this point, right? She is checking out code. You know, she's sharp as a tack and making sure that, you know, holding people accountable, holding instructors accountable, right? So I am happy that she found that flaw, right? Because I'd hate to have that video up here and be misinforming people. But that's why I'm using the array length, right, for the size. I'm passing that in as a argument. So now, again, just to reiterate, when you passing in an array of pointers, then it's a pointer to pointer, right? The array, you have to declare it like this, right? Person array with the 2 stars, star, star, and then the function itself, obviously, and then this works. Okay, so I'm going to run it one more time before we take off just to see what it looks like. And I'll clear the screen and compile it and run it. And that's it. Okay, I hope you enjoyed this video, and I will see you in whatever next one you watch. Not so fast. Let's see how this runs on Windows. So let me switch to a different VM. Let me pull up git bash window. So, oops. Okay. Change CD to dev and CD C_bootcamp. I think that text is big enough. Let me do a git pull, make sure I'm up to date. Okay, so change directory to dynamic allocated. Okay, so CLS and /gcc main.c. Okay, and do a director dir. All right, so we have a.exe on Windows, right? So clear the screen, /a.exe. All right, so it works. So let's see what happens. I'm going to actually modify this program a little bit here, right? So I'm going to pull up Visual Studio Code on Windows and close that side down, close that. I got my main. There we go. Now, let me see the part I want to change. So here I'm allocating. So when I actually set these to null, before I set this to null, I want to see what these are set at actually by default. So I'm just going to create another for statement. Int I equals 0. I less than array length I plus plus open brace, closing brace. And then I'm going to say printf. And I'm just going to say, quote, I think say element, I'm going to say element value, element is null. I'm just going to say is null. There we go. Programming live. Gotta love it. All right, and then I guess this would be an integer, but we'll see what happens. %d. Actually, I'm going to say percent string s. Okay, and then comma. There we go, comma. And then I'm going to use one of those three-way conditional expressions. So bool, people array I equals null, and then question mark. All right, and then return yes, and then or no, like that. So let's run this one. Actually, let me do a carriage return slash n, or new line. All right, so printf people array null. Yes, no. So let's run this and see. No, I have not initialized it. So I'm just checking to see if they're automatically initialized to null. It's nice to know if that is the case. So let's go to the console. And so GCC, clear the screen, and then run it. It appears not. Now let's actually repeat this. And let's do this. So after the null, Control C. After the null, we're going to do the same test. Save. So here, I have not initialized each element to null. Okay. I'll do another test too to see what it is initialized to. But let's do this now. Okay, so we saved it. So clear the screen, compile it, and run it. So yes, right. So there's a difference between setting something to null. Okay. Now let's try this on Mac OS and see if there's a difference. Okay. So let me push these changes up to the repo. So git status. All right, so I've modified that one. So git add. All right. So git commit -m tweaked array example git push. All right, so now let's switch to Mac OS, and then I'm just going to say git pull. All right, so we've got the latest here. So I'm going to close this. Well, all right. See if it shows up here. Oops. Don't save, just in case. All right, so code. Oops. Dot. Let's just make sure we got the right copy here. Main.c. So yes, we do. Okay, so let's run this in Mac OS and see what the results are. So clear the screen, gcc main.c, and then /a out. There's a difference. There is a difference. So on Mac OS, it appears that if you do not allocate, they are null. Okay. By default. And on Windows, it appears that, let me run this program. They are not null by default. That's interesting. Okay, so it seems to me like the general conclusion, right, is that variations of C on different platforms may produce strangely different results, right? So that's why I always, like to initialize elements to null to make sure I know what the state is. Okay, so that's that. That's the lesson learned there. Okay, thank you. Now I think I'm actually done, right? I just wanted to add this little piece to it. So have a great day.